today we're going to talk about the volume and surface area of cones. So recall that a circular cone or cone has a circular base and a vertex that is not in the same plane as the base. Now the altitude or the height is perpendicular distance between that vertex and the base. In a right cone, the height meets the base at its center, and the slant height is the distance between the vertex and a point on the edge of the base. Now, what about the lateral surface? Well, the lateral surface of a cone is all of the segments that connect the vertex with the points on the edge of the base. If we were to cut along the slant height and lay the right cone flat, you're going to see this net, okay? In the net, the circular base has an area of pi r squared, and the lateral surface is a sector of the circle. Notice that the slant height, we use a cursive L to represent that. The surface area of a right cone is pi r squared plus pi r times the slant height of L. All right, let's take a look at a surface area problem. We have this right cone and we want to find the surface area. Well, I know that the slant height is 6, and I know that the radius of the circle is 4 inches. So I know to find the surface area, it's pi r squared plus pi r times the slant height. So if I replace the variables with what I know, I'm going to get pi times 4 squared plus pi times 4 times 6, and I'm going to get 16 pi plus 24 pi. Now, when I finish it out, I get the surface area is about 40 pi, or approximately 125.66 square inches. Okay, so now to find the volume of a cone, it looks very similar to the volume of a pyramid. Well, the volume of a cone is equal to 1/3 times the area of the base times the height. But remember, the area of the base in this case is a circle, so it's pi r squared times the height. Okay, so let's look at this problem. We're to find the volume of the cone, and this time it's not a right cone, but we're still going to do the same exact thing as if it were a right cone. The height is 4.5 centimeters, the radius is 2.2 centimeters, and when I plug and chug, replacing my variables with what I know, I'm going to get that the volume is about 7.26 pi, or 22 81/100 cubic centimeters. All right, one more problem. This time we have cone A and cone B, and they are similar. It tells me that in the directions. I know that cone A has a radius of 3 and a volume of 15 pi cubic feet. Cone B, I know, has a radius of 9. Well, the first thing I need to do is find the scale factor, the radius of B over the radius of A, because that's what I know. And when I simplify it, it equals 3. So now I'm going to go to the volume of B over the volume of A. I know that that is going to be K cubed. So let's plug in what we know. We don't know the volume of B, but we do know the volume of A is 15 pi. We also know that the scale factor was 3, and because it's volume, we're going to cube it, so it's going to be 3 cubed. When I do the math, I find out the volume of B is about 405 pi.